In this video, we are going to learn how to calculate the mean, median, and mode of a group data. The table below shows the height of tomato plants taken in an experimental plot. Now we are given the height and the numbers of plants. Let's proceed to calculate the mean, median, and mode.
Okay, let's start by constructing our table. So this is the table that I constructed. I have not done anything. I only changed the table from horizontal form to vertical form. You understand? I still have the height and the numbers of plants. Now I want you to note something. You can see that the height, the class interval is the height. The class interval, let me call it CI. The class interval is the height, and the numbers of plants is the frequency. Let me call this frequency. You understand? Frequency. You understand? So this is frequency, and for the first class interval, the frequency is 6, followed by 8, followed by 9, followed by 10, followed by 8, 5, and 4. Okay, now before we proceed, let's start with the first question. You can see that we are told to calculate the arithmetic mean. Now, don't forget, when you are dealing with statistic on, a group data, it is very, very important that you remember your formula. Are you getting what I'm saying? The first step is that you have to remember your formula. The formula for arithmetic mean of a group data is given by this. X bar is equals to summation fx all over summation f. Do you understand? The first step is that you are going to remember your formula. So now your formula will define what you are going to have on your table. You understand? When you remember your formula, the parameters that you need in your formula, the parameters that you need to calculate in your formula, that will tell you what you are going to have on your table. Do you understand? Now look at this formula. We need the product of frequency and x. Though I have my frequency as the numbers of plants, but I still need to find the value of x. How do I determine the value of x? So that will give me another, we have another table here, which will stand for x. Do you understand? Sorry. I'm going to have another table that will stand for x. Okay. Okay. Please, I want you to pay attention, okay? So now, to get the value of x, it is very simple. Just find the midpoint of your class interval. You understand? The midpoint of your class interval is the respective value of x. So to get the value of x of this cell, I'm going to find the midpoint of this class interval. Don't forget, from this class interval, I have the upper class interval and the lower class interval. All the values here are the upper class interval, and all the values here are the lower class interval. So to get the midpoint of this, I'm going to sum the upper class interval, that is 21.8 plus 21.5. The upper class interval and the lower class interval divided by 2. Do you understand? That will give me the midpoint of these cells. Are you getting it? So the midpoint of these cells is the midpoint, the value of x for these cells will be the midpoint of the respective class interval. You understand? So if you punch your calculator, you're going to get 21.65. So this is 21.65. Okay? So let's get the midpoint of this cell. To get the midpoint of these cells, we are going to add this upper class interval and the lower class interval and divide it by 2. That is what I call the midpoint. You understand? So let's say this is 22.2 plus 21.9. 21.9 all over 2. So if you punch your calculator, you're going to get 22.05. So the value here is 22.05. So let's get the midpoint of this. To get the midpoint of these cells, we are going to add both the upper class interval and the lower class interval and divide it by 2. You understand? So for this, I'm going to have 22.6 plus 22.3 divided by 2. So that is 22.45. 22.45. So for these cells, I'm going to have 23.0 plus 22.6 divided by 2. So that is 22.85. 22.85. 22.85. Okay, so let's get the value of x for this cell. That will be 23.4 plus 23.1. 23.4 plus 23.1 divided by 2, that is 23.25. 23.25. Okay, let's get the value of x for these cells. That is 23.8 plus 23.5 divided by 2. That is 23.65. 23.65. Okay, the last midpoint, the last value of x, which is for these cells, that is 24.2 divided by 23.9. That is 24.05. 24.05. So, having gotten the value of x, let's go back to the formula. From the formula, we still need the product of f and x. Okay, so I'm going to have another table. You understand? I'm going to have another column rather. I'm going to have another column which will stand for fx. Don't forget that fx means the product of the frequency and x. Okay, please, I want you to pay attention. I start from telling you that you have to first remember your formula. You understand? And I wrote the formula here: summation fx all over summation f. And from this formula, though we have been given that we have been given the value of f, but I need to determine the value of x. That is how I take the midpoint of the class interval, and I got the value of x. Having determined the value of x, I still go back to the formula. I need the product of fx. Okay, so I have another column for fx. Now let's go. The frequency, the value of these cells will be the product of frequency and the respective value of x. Are you getting it? Please, I want you to pay attention. Fx is, for example, the value of these cells. The value of these cells will be the product of the respective frequency and x. Okay, so for these cells, I'm going to have 6 multiplied by 21.65. Do you understand? I wrote it here so that you understand. For this cells, I'm going to have 8 multiplied by 22.05. For these cells, I'm going to have 9 multiplied by 22.45. Okay, for these cells, I'm going to have 10 multiplied by 22.85. And for these cells, I'm going to have 8, which is the frequency, multiplied by 23.25. And for these cells, I'm going to have 5 multiplied by 23.65. And for these cells, I'm going to have 4 multiplied by 24.05. Okay, so let's start from this cell. 6 multiplied by 21.65, that is 129. 129. Don't mind my writing, okay? Just pay attention. 129.9. Okay, so for these cells, 8 multiplied by 22.05, that is 176.4. Okay, so for the next cells, that is 9 multiplied by 22.45, so that is 202.5. 202.05. Okay, let me just put it. Now for these cells, that will be 10 multiplied by 22.85. This is 5. Okay, 10 multiplied by 22.85, that is 228.5. Okay, for the next cells, 8 multiplied by 23.25, that is 186.0. 186.0. And for the next cells, that is 5. This 5 multiplied by 23.65, that is 118.25. 118.25. Okay, so for the last cells, that is 4 multiplied by 24.05, that is 96.2. 96.2. Do you understand? So now, having determined the value of the product of fx, let's go back to the formula. From the formula, we need the summation of fx. You can see. So we progress as you can. Immediately you remember your formula, half of the problem is already been solved. You understand? Because the formula will tell you what you are going to have on your table. Okay, so now from the formula, I still need to sum the fx. Are you getting it? So I'm going to the summation of fx simply means the sum of the product of fx. I've already taken the product, so I'm going to sum that column. Okay, that is 129.9 plus 176.4 plus 202.05 plus 228.5 plus 186.0 plus 118.25 plus 96.2, that is 1137.30. 137.30. Okay, so this is the fx. Okay, that is the summation of fx. Now, so we are done with this numerator. let's go to the denominator of the formula. That is summation f. Summation f means summation of all the frequency. So the frequency is the number of plants. So I'm going to sum all the frequency here. The sum of all the frequency here is 6 plus 8 plus 9 plus 10 plus 8 plus 5 plus 4. What's the answer? 50. Okay. So the answer, the sum of the frequency is 50. So having gotten the value of fx and the having gotten the summation of fx and the sum of the frequency, then we can proceed to use the formula. Okay, so the formula for mean, which is x bar, is equals to summation fx, which is 1137.30 all over summation f. Summation f is what? 50. So for this I'm going to have 50. So the value of x bar here is what? Divide it, you are going to get, let's see, 22.746. 22.746. Okay, so you can approximate to 2 decimal places. Okay, so that is 22.75. okay, so the mean of this data is 22.75. so having gotten the mean, let's proceed to calculate the median. Now don't forget the step that I told you. The first step is that you're going to remember your formula, because your formula will tell you what you are going to have on your table. Okay, so let's go. Recall that median is given by this formula. Median is equals to lower class boundary plus n over 2 minus CFB all over FM multiplied by height. I'm very sure you can see the formula that I wrote here. If you can't see it, let me rewrite the formula here. Median, let me call it MD, is equals to Li plus n over 2 minus CFB all over FM multiplied by height. You can see, I'm very sure if you can't see this formula, you can see this one. Okay, so let us proceed. Now, from this formula, let me start by telling you the parameters that we have in the formula. The Li that you see in that formula stands for lower class boundary of the median class. Okay, write it down. Li stands for lower class boundary of the median class, and N is the total numbers of plants, that is the total numbers of frequency. Okay, and CFB is the cumulative frequency before the median class. Are you getting it? CFB is the cumulative frequency before the median class. FM is the frequency of the median class. Please pay attention as I am telling you those parameters. FM is the frequency of the median class. High is the class width. Are you getting it? So Li is the lower class boundary of the median class. Li is the lower class boundary of the median class. N is the total numbers of samples, total numbers of observation, total numbers of plants. You understand? And CFB is the cumulative frequency before the median class. Are you getting it? And FM is the frequency of the median class. High is the class width. That is the class width. Okay, so let's proceed. Now from this formula, you can see that we cannot do anything unless we determine the class interval of the median class, because it is from the class interval that we are going to derive our class boundary. Okay, just pay attention, you are going to understand. Okay, just pay attention. Now let's start. To determine the class interval of the median class, we need to construct the cumulative frequency table. Do you understand? We need to construct the cumulative frequency table. So I'm going to have another column which is part for cumulative frequency, CF. Okay, CF. Please, do you understand? CF stands for cumulative frequency. Okay, now cumulative frequency is the summation of the subsequent frequency. To get the okay, let me put it like this. To get the cumulative frequency of a cell, the cumulative frequency of the cell is the summation of all the frequency before the cells. Are you getting it? For example, to get the cumulative frequency of these cells, I'm going to sum all the frequency before the frequency of these cells. Are you getting what I'm saying? For example, look at this. Is there any frequency before 6? There is no frequency. That will be 0 plus 6. So I'm going to have 6. Please, are you paying attention? Just pay attention. You're going to understand, okay? Cumulative frequency is, when you talk about cumulative means addition. You understand? Cumulative, summing up. Are you getting it? So now, cumulative frequency of these cells will be the sum of the frequency before the cells and the frequency of the cell itself. Are you getting what I'm saying? The cumulative frequency of these cells will be the sum of the frequency before the cells and the frequency of the cell itself. But there is no cell before this 6. So I'm going to have 0 plus 6. That is what? 6. Okay? That is how I got the cumulative frequency of these cells. Okay, let's go to the second cell. To get the cumulative frequency of these cells, I'm going to add all the frequency before the frequency of these cells and the frequency of the cell itself. For example, to get the frequency of these cells, I'm going to add 6, which is the cumulative frequency before the frequency of the cells, and the frequency of the cell itself, which is 8. Okay? That will be 6 plus 8. That is 14. Please, do you understand? So now let's get the cumulative frequency of these cells. So I'm going to add the frequency that is before the frequency of these cells and the frequency of the cell itself. You understand? I'm going to add the frequency before the frequency of these cells. Okay, now look at these cells. I want to determine the cumulative frequency of these cells. The frequency of the cell is what? 9. So I'm going to add all the frequency before this frequency, then add this frequency itself. Just like saying 6 plus 8 plus 9. That will give me the cumulative frequency here. Are you getting it? 6 plus 8 will give me the cumulative frequency here. 6 plus 8 plus 9 will give me the cumulative frequency here. So if you add 6 plus 8, if you add 6 plus 8 plus 9, we are going to get 23. You understand? So for this, I'm going to have 23. This will be 23. Okay? So for these cells, the cumulative frequency of these cells will be 6 plus 8 plus 9 plus 10. That will be 33. Do you understand? So the cumulative frequency of these cells will be 6 plus 8 plus 9 plus 10 plus 8. That will be 41. Please, do you understand? So to get the cumulative frequency of these cells, that will be 6 plus 8 plus 9 plus 10 plus 8 plus 5. That is 46. So to get the cumulative frequency of these cells, that is 6 plus 8 plus 9 plus 10 plus 8 plus 5 plus 4. That is 50. Okay? So the cumulative frequency here is what? 50. You don't need this, okay? You don't need any, we are not summing the cumulative frequency. You understand? So you don't need any brackets here. The reason why I put additional cells in this place and this place is because I need the sum of the frequency when I'm calculating the main, and I also need the sum of the product of the fx. Are you getting it? So I don't need anything here, so there is no need of putting cells. So having determined the cumulative frequency, don't forget our aim. Our aim is to determine the class interval of the median class. So we have already gotten the cumulative frequency. Now, how do we determine the class interval from the cumulative frequency? We are going to start by dividing the total numbers of frequency by 2. That's the next step. We are going to divide the total numbers of frequency by 2. The total number of frequency is what? N. That is n divided by 2. You understand? N is what? 50. So I'm going to have 50 divided by 2. That is what? 25. Now, the next step is that I'm going to locate where 25 fell into among my cumulative frequency column. You understand? Don't forget that this is the cumulative frequency column. Now, where does 25 fall into? You can see that this is the place where 25 fell into, because 25 is greater than 23 and it is less than 33. You understand? 25 is greater than 23 but less than 33. So 25 falls in this range. You understand? So the class interval that belongs to where 33 is, that is the class interval of the median class. You understand? Let me asterisk it. You understand? This is the class interval of the median class. Please, do you understand how I got this? Do you understand how I got it? Look at this. After constructing your cumulative frequency table, divide the total numbers of frequency that you have by 2. Just like this, n over 2. Divide the total numbers of frequency that you have, divide it by 2. So when I divide the total numbers of frequencies that I have, I divide it by 2, then I got 25. So I locate where 25 falls into in my cumulative frequency column. And the values of my cumulative frequency, I locate where 25 fell into. I realized that 25 is greater than 23, so 25 cannot be here. 25 falls within this range. So the class interval that belongs to this row is the class interval of the median class. Do you understand? Okay. Now, having determined the class interval of the median class, now let's determine the parameters that we need in the formula. Don't forget that I told you Li is the lower class boundary of the median class. Let me write out the class interval of the median class. The class interval of the median class is 22.7, 22.7, and 23.0. Do you understand? 22.7 and 23.0. So the upper class interval, this is the upper class interval, and this is the lower class interval. You understand? So let us get the class boundary. To get the class boundary from the class interval, since the class interval has both lower and upper, class boundary is also going to have both upper class boundary and lower class boundary. So to determine the class boundary from the class interval, I'm going to subtract 0.5 from the lower class interval and add 0.5 to the upper class interval. Please, do you understand? I'm going to subtract 0.5 from the lower class interval to get the lower class boundary and add 0.5 to the upper class interval to get the upper class boundary. Do you understand? So let's go. For this, I'm going to have 22.7. Sorry, let me change the marker. 22.7 minus 0.5. Then this is dash, so it's not minus, okay? 23.0 plus 0.5. This is not part, okay? Let me just erase it. Are you getting it? I subtract 0.5 from the lower class interval. Don't forget that this is lower class interval and this is the upper class interval. I subtract 0.5 from the lower class interval and add 0.5 to the upper class interval. So this is my class boundary. So let's proceed. 22.7 minus 0.5, that is 22.2. Then 23.0 plus 0.5, that is 23.5. So you can see this is the class boundary. Okay. So now, but I want to pay attention. From the formula, we need the lower class boundary. So I'm going to write it somewhere. Lower class boundary Li is equals to 22.2. You understand? So let's look at what we still need from the formula. We need the cumulative frequency before the median class. Don't forget that this is the median class. So it is not frequency before the median class. It is the cumulative frequency that we need. The cumulative frequency before the median class. So this is the median class. The cumulative frequency of the median class. This is the cumulative frequency of the median class. The cumulative frequency before the median class, that is 23. So CFB is equals to 23. You understand? Please, it is very, very important that you pay attention there. It is not the frequency of the median. It is not the frequency before the median class that we need. It is the cumulative frequency before the median class. That is what CFB stands for. Okay. So now we need the frequency of the median class also. So this is the median class. The frequency of the median class is 10. So FM is equals to 10. Are you paying attention? Okay. So we still need the I. I is the class width. The class width is the difference between the class boundary. You understand? Don't forget that this is the class boundary. So the difference between this class boundary is what? 23.5. Class width is, let me just put the formula. Look at this formula. Class width I is equals to upper class boundary minus lower class boundary. You understand? Upper class boundary. U stands for upper. CB stands for class boundary, okay? Upper class boundary minus lower class boundary. So for this, I'm going to have 23.5 minus 22.2. So subtract, you're going to get 1.3. So this is 1.3. So the class width is equal to what? 1.3. You understand? So we have gotten all the parameters that I need in the median formula. So we can proceed to use the formula, okay? So when you are dealing with statistics, especially or any subject that involves calculation, always remember your formula, okay? So that by the time you remember your formula, you're going to know what you're going to have on your table, okay? So let's proceed. So median is equals to Li, which is the lower class boundary. Lower class boundary is 22.2. So 22.2 plus n over 2. Don't forget that n over 2 is what? 50 over 2. Do you understand? N over 2 is the numbers of frequency, total numbers of frequency. You understand? So the total numbers of frequency is 50. That's why I got 50 over 2. 50 divided by 2 is 25. You understand? So I'm going to have 25 minus CFB, the cumulative frequency before the median class. That is what? 23. So I'm going to have 23 whole over FM. FM is what? 10, because that is the frequency of the median class from what we got here. So I'm going to have 10 here, multiplied by class white. The class white is what? 1.3. So 1.3. See, do you understand? Okay, so let's proceed. The median is equals to 22.2 plus 25 minus 23, that is 2. 2 over 10 multiplied by 1.3, okay? So the median is equals to 22.2 plus 2 over 10, that is what? 1 over 5. 1 over 5 is 0.2. So plus 0.2 multiplied by 1.3. Please, I want to pay attention. I'm just simplifying what I have in the formula. I'm not doing anything. Just have to pay attention. You understand, okay? So I'm just simplifying what I have in the formula. You can see, I'm very sure you understand to this point, okay? So I have 22.2, 25 minus 23, that is 2. All divided by 10, multiply by 1.3, that's what I did. And then I got to this point, 2 divided by 10, that is what? 1 over 5. 1 divided by 5 is what? 0.2, you understand? So 0.2 multiplied by 1.3, then the median will be equal to 22.2 plus 0.2. And when you got to this point, please follow the rule of BODMAS, okay? So that you will not mistakenly add 22.2 plus 0.2 and then multiply. You won't get the right answer, okay? So follow the rule of BODMAS, okay? Take the multiplication, take the product of 0.2 and 1.3, then you add it to what? 22.2, okay? So that is, if you take the product of this, you are going to get 0.26. 0.26, so 26. So the median is equals to 22.2 plus 0.26, that is 22.46. So 22.46. So the median here is 22.46. I'm very sure you understood how I got the median is 22.46. Now, having gotten the median, let's proceed to get the mode. Now, what is the first step? The first step is that you have to first write out the formula. So the formula will define what you're going to have on your table, okay? So let's proceed. Okay, mode is given by this formula. The mode of a group data is this. Mode is equals to the lower class boundary of the modal class plus multiply by high. Can you see what I wrote there? Maybe I should just, let me write it again. Look at this. Mode is equals to lower class boundary of the modal class plus delta 1 over delta 2 and delta 1 plus delta 2 multiplied by high. Okay, I'm going to tell you the meaning of the parameters and the formula. Now, you can pen it down. Li stands for the lower class boundary of the modal class, okay? Li stands for the lower class boundary of the modal class. Delta 1, that is this sign. This sign means delta, okay? This sign means delta. The sign here means delta, okay? That is change, okay? Delta 1 is the difference between the frequency of the modal class and the class before it. Do you understand? Delta 1 is the difference between the frequency of the modal class and the class before the modal class. Okay? Delta 2, which is the second delta. Delta 2 is the difference between the frequency of the modal class and the class after the modal class. You understand? So, and I is the difference between the class boundary of the modal class. So, we cannot do anything unless we determine the class interval of the modal class. Do you understand? To get the class interval of the modal class, the class interval of the modal class is the class interval that has the highest numbers of frequency. Are you getting it? The class interval which the highest numbers of frequency belongs to, that will be the class interval of the modal class. So let us check. The frequency here is 6, 8, 9, 10, 8, 5, and 4. Which of this frequency is high? It is 10. So the modal class is what? This is the modal class. 22.7, 22.7, 22.7, and 23.0. That is the modal class. Let me write it out. The modal class. The modal class. That is 22.7 and 23.0. You understand? So now we want to determine the class boundary. Okay? We want to determine the class boundary. How do we determine the class boundary? You have to subtract 0.5 from the lower class interval. This is the lower class interval. You understand? Lower class interval, upper class interval. You understand? So now, to determine the class boundary, you have to subtract 0.5 from the lower class interval and add 0.5 to the upper class interval. Do you understand? So for this, I'm going to have 22.7 minus 0.5. Though I have already done it the other time when I'm calculating for me. But for you to understand, you have to do, let me just repeat the same process, okay? So for this, I'm going to have 23.0 plus 0.5, okay? So this will be what? 22.2 and 23.5. So this is the lower class boundary and this is the upper class boundary. You understand? So now, but I only need the both. Yes, I need both. You understand? So the lower class boundary is what? 22.2. Let me write it out. Lower class boundary, which is Li, is 22.2. So let me quickly determine the class width, which is I. Don't forget that I is the difference between the upper class boundary of the modal class and the lower class boundary of the modal class. So 23.5 minus 22.2, that is what? 1.3. So I is equals to 1.3. Do you understand? So now let's go to delta 1. Delta 1 is the difference, that is this delta. Delta 1 is the difference between the frequency of the modal class and the frequency before the modal class. Are you getting it? Please, I want to write it down. Delta 1 is the difference between the frequency of the modal class and the frequency before the modal class. The frequency of the modal class is what? 10. You understand? So the frequency before the modal class is what? 9. The frequency of the modal class is what? 10. The frequency before the modal class, FBM, is what? 9. And delta 1 is what? FM minus FBM. That is 10 minus 9. Do you understand? Please, I want you to understand, okay? The frequency of the modal class is what? 10. The frequency before the modal class is what? 9. Come here. This is the frequency of the modal class. The frequency before the frequency of the modal class is what? 9. That is how I got 9. So 10 minus 9 is what? 1. So delta 1 is what? 1. Delta 1 is what? 1. Okay, let's determine the value of delta 2. Delta 2 is the difference between the frequency of the modal class and the frequency after the modal class. You understand? So the frequency of the modal class is what? 10. The frequency after the modal class is what? 8. So I'm going to have 10 minus 8. Do you understand? So 10 minus 8 is what? 2. So I'm going to have delta 2 is what? 2. Do you understand how I got all the parameters? So having gotten all the needed parameters in the formula, we can now proceed to use the formula to calculate the mode of the data. Okay? Mode is equals to Li Li is 22.2. So 22.2 plus delta 1. Delta 1 is what? 1. So I'm going to have 1 over delta 2. Delta 2 is what? 2. 1 over delta 1 plus delta 2. So I'm going to have 1 plus 2 multiplied by I. I is what? Class width, which is 1.3. So mode is equals to 22.2. Okay, we can still simplify this. 22.2 plus 1 over 3 multiplied by 1.3. Okay, don't forget that it is important that you make use of BODMAS. Okay, so we go for the division first, or bracket. 22.2 plus 1 divided by 3, that is 0.333. Abi, let me check. Yeah, 0.3333 multiplied by 1.3. Okay, so the mode is equals to 22.2. Now I want to take the product of 0.333 and 1.3. That is 0.433 plus 0.433. You understand? So now if you add this together, you're going to get the mode. The mode here is what? 22.2 plus 0.4333. That is 22.63. Do you understand how I got this? So the mode of the data is 22.63. Please, you can see how I simplified it. Okay, anytime you are dealing with statistics, especially maybe you are your question requires table, the first step is that you have to remember your formula. That's the int. So after you remember your formula, that formula will tell you what you are going to have on your table. Okay, you understand? So that is how, by so doing, you have already solved half of the problem. When you remember the formula, the exact formula that you need to solve the question, when you remember it, you have already solved half of the problem. You understand? So that is it. See you in the next class. Okay.